And welcome back to the second half of Monday's lecture video. I hope you don't mind. I like to cut it in half because once in a while, somehow the audio doesn't get recorded or something, and then I have to start over making these video lectures, and it's just way too discouraging after like making like an hour worth of a video and find out that the whole thing was, useless. So anyway, and also I think for videos, it's kind of hard to watch like a really long one, so it might be good for you to have two shorter videos instead of one long one. Anyway, remember we've been talking about acetals and hemiacetals and how acetal is formed by the sort of successive nucleophilic addition of two total molecules of alcohol. If you only add one, you get hemiacetal. If you add two, you get acetal. Now, if you're a chemist, this is the kind of thing I want you to be curious about. Like, so we added a weak nucleophile like alcohol to a carbonyl. What happens if you add a little bit stronger nucleophiles, like say an amine, nitrogen? If you swap this out with nitrogen, what would you get? And of course, in a biological system, you have a lot of carbonyl molecules and amine molecules. Those are pretty abundant type of functional groups in physiology. So as we'll kind of talk about, imines are really important functional groups. And you might ask, well, dude, what is an imine? Well, imine is what you get if you mix a carbonyl, or if you react carbonyl with an amine, especially if you have a primary amine, primary amine, you get this. Okay. You don't get something that looks like acetal with sp3 carbon. You do end up with an sp2 carbon, and that's called an imine. But this is kind of the nitrogen version of acetal, is kind of what you can think about it. And another reason why we say that this is basically the nitrogen version of acetal is just like with acetal formation, the byproduct would be water, okay? And if the R prime group is hydrogen, then that would be, I hope it makes sense, that would be an aldehyde. If the R and R prime are both carbons, then this would be a ketone. So you could make the takeaway here, right here, would be, as in takeaway of this is just that you can make imine from either an aldehyde or a ketone. So how would the mechanism work? Well, this is very much the same, or similar at least, to acetal formation. So we might go rather quickly. In fact, I took the liberty of skipping the first step. But now in lecture, sometimes we skip steps, but like if quiz or exam, if we ask you for a step-by-step full mechanism, you should show the full mechanism, okay? I'm just skipping steps to save time during class so we can talk about more examples or more pertinent things instead of being too redundant. So once the carbonyl is, of course, protonated, remember that makes it more electrophilic, strongly electrophilic. Amine is a pretty good nucleophile anyway, but it's not like the strongest nucleophile. But with that additional activation of the carbonyl, it would be this would be a very reasonable reaction, nucleophilic addition of the amine to the activated carbonyl. And at this point, we would have this tetrahedral intermediate where the carbon that used to be sp2 in flat is now sp3, and through rapid proton transfer, if the proton moves around, we do see a potentially good leaving group like water here, right? And just like the oxygen in the acetal formation, nitrogen also in the neutral form has this lone pair that could be used to push off the water. And once deprotonation to make it neutral would occur, you get your imine. You could also think of imine as the sp2 version of an amine. In the old days, this was called Schiff base. Because it's still basic, but it's not amine like basic, you know. And then, of course, the byproduct is water, or you could say the acid catalyst, or hydronium ion. Even for this, the Dean-Stock apparatus is a good idea because you are indeed working with all reversible steps and you're producing water. So if you can remove water from the equilibrium, the reaction occurs pretty well. By the way, this is called an iminium ion because it's a cation version of the imine. Technically, there's a controversy about how to spell iminium ion because that could be spelled as like how I wrote it, but or with two M's. But I believe the two M spelling is predominantly British, and since we're not British, we're Americans, we want to be patriotic and stick with the American spelling here. Now, maybe this would be a good place to pause the video to see if you can fill in the blank here. In this additional example, I want you to figure out what the starting materials would have been to make this imine molecule. Okay, so pause the video and see if you can figure it out. Okay, of course the answer would have been this ketone and this primary base, or amine, I should say. Hope it makes sense to you that this is where you should sort of cut the molecule in half, so to speak. Okay. Now, I feel like I didn't really provide enough examples here, so I might say if you were to react the same ketone with something like ammonia or ammonium ion. So ammonium ion would be the combination of acid catalyst and an ammonia nucleophile together. These would together give you also this kind of an imine. That's another example. That'll be where this R double prime would be just another hydrogen. Here's another example. What if you had the amine in the same molecule? What could happen? Of course, with the help of acid catalyst, you could form an intramolecular imine like that. Okay. Just like we learned with acetals and hemiacetals, because these are all reversible steps, like the inverse or the opposite of imine formation can happen if you have enough water to drive the reaction. Think Le Chatelet's principle, right? Like if there's a lot of excess amount of the starting material, reaction could be driven towards the product, right? And so for that reason, typically you do this in excess water, which in practice just means you use water as the solvent. And then there's a lot of that. So you can get your carbonyl compound back. Okay, and amine. All right, so okay. Now the mechanism, this would be a really good time to pause the video and see if you can figure out the mechanism on your own. It should be very similar to the acetyl hydrolysis. It's a really good skill for you to be able to develop if you can look at when it comes to a similar mechanism similar to the ones that you've learned before, for you to be figure out the new mechanism based on that analogy, similarity to something you already know. So I think you should be able to figure this mechanism out on your own. So pause the video and try it. But also this is the mechanism that's the opposite of imine formation. So another reason why you probably want to be able to figure this out on your own. So pause it and see. Okay. Here I'm taking the liberty once again. I skipped the first step, as in I already protonated the imine. So please know that there is a step in the mechanism. But once it's protonated, this is just like the activated carbonyl, right? It's very electrophilic, and so for that reason, even a weak nucleophile like water could attack that. So this would happen, nucleophilic attack. This is the opposite. The mechanism is the opposite of imine formation. And once the water adds, I hope it makes sense to you that this is the tetrahedral intermediate that you would get. And here you have your extra proton that's giving the oxygen the positive charge. But remember, rapid proton transfer principle, the proton can hop around between any heteroatom at any given time. Kind of messed up the arrow, so I should, yeah. And so at any given moment, that new or the extra proton could be on this nitrogen. And once that happens, the nitrogen cation could be pushed off as a neutral amine, like so. And once deprotonation occurs, then you have your recovered ketone and the recovered primary amine. Okay, so example of that, let's say if you started with this imine, treat that with a bunch of water and acid catalyst, you could get back your acetone, and in this case methylamine. Okay. Now here's an example. I want you to see if you could predict the product. It would be a good time to pause the video. What would be the hydrolysis? What would you get if you hydrolyze this imine? And I want you to recognize this as an imine right there. Okay, so pause the video. All right. The product should look like this, and Again, anytime you do these kinds of example problems, it would be a good idea for you to see if you could figure out the mechanism on your own. Okay, that would be a good studying session right there after this lecture. So, okay, where we are heading from here, like we want to look at the imine formation, which is answering the question like what would happen if a secondary amine like this instead of a primary amine like this reacts with ketones, or I should say carbonyls, and some other carbonyl reactions, okay, in the next lecture. So in the next lecture, I'm gonna, because I kind of forgot to cover it within this lecture, I'm going to cover the nomenclature problem. So before you watch the next one, please take a look at 19.2 in your Klein textbook.